Hello everyone, welcome back to a lecture series on overview and integration of cellular metabolism. We are studying heme metabolism and this is the second class where we will be discussing the disorders of heme synthesis or porphyrias, alright. So, the concepts that we will be covering today are the pathway of heme synthesis that you already know, we will be revising that, the defects in the enzymes that are there in pathway of heme synthesis that leads to these diseases known as porphyrias, what are the types and varieties of porphyrias, what are the symptoms, how we can diagnose and how we can treat them, everything we will be covering in this lecture. Now, you all remember, right, from the last class of heme synthesis how the initial two products succinyl coenzyme A and glycine was combining to form delta amino levulinic acid, okay, del ALA, okay, delta amino levulinic acid, this is the sign of delta, right. And in the next step we discussed how two molecules of delta amino levulinic acid were combining to form one molecule of porphobilinogen, right. But in reality we discussed that 4 of these porphobilinogen will be required. So, in total 8 ALA are needed. So, first it forms a porphobilinogen which forms a linear tetrapyrrole, this is not yet circular, I mean this is not, the ring is not closed, which is also known as hydroxymethylbilane, alright. Thereafter it transforms into uroporphyrinogen 3, alright, which again transforms into coproporphyrinogen 3, then it converts to protoporphyrinogen 9, then it converts to protoporphyrin 9 and finally with the help of iron it converts to heme, alright. So, most of you who have already gone through that class, I hope you have easily remembered the steps. If not, this is a very good way to remember it, okay. If you are having if you are struggling in remembering, I have got a very good mnemonic for you. The mnemonic states that some good doctors prefer hugs under cover produces perfect healing, alright. So, I have given illustration diagram and this concept is actually very important where a doctor hugs his patient. It has been depicted in many Bollywood movies, Munna Bhai MBBS for example, Jadoo Ki Jappi. But the thing is, if you can just relate this mnemonic and the initials, you can easily remember that the products that are coming in succession in one another, right. So, succinyl CoA, glycine, delta amino levulinic acid or ALA, then porphobilinogen, first linear tetrapyrrole hydroxymethylbilane, uroporphyrinogen 3, coproporphyrinogen 3, protoporphyrinogen 9, then protoporphyrin 9 followed by heme, okay. It is a very good way to remember if you are struggling, okay. But if you have been able to memorize and remember, I applaud you, right. Not only the products you have to remember, but you will also have to remember the enzymes that were catalyzing the reactions. The first enzyme is ALA synthase that helps in combination of succinyl CoA and glycine, right. Thereafter ALA dehydratase, hydroxymethylbilane synthase is also known as porphobilinogen deaminase. This enzyme has got multiple name, or even uroporphyrinogen 1 synthase, right. Thereafter uroporphyrinogen synthase is also known as co-synthase, right. Then decarboxylase 2 oxidase enzyme and last enzyme is ferrochelatase. So, is there any way to remember this as well, right? There is, right. So, I give you another mnemonic, Aunt Alice has unusually useful crafting powers, friend, right. So, remember magician Aunt Alice who can craft many things by waving her magic wand, right. So, you can again see the initials of this mnemonic corresponds to the enzymes, right. So, why we are stressing so much in remembering all of these products in sequence and all of the enzymes? Because this is very important. I told you in any metabolic disorder, what we will be studying today is the disorder of these enzymes, right. So, any enzyme if it gets deficient or it has got low activity, what I told you, the product before that will get accumulated and the product after that will be deficient. This is the basic rule of any metabolism. So, unless you know what comes after another in sequence, it will be very difficult for you to conceptually write the answers, right? If you can just memorize, but then again there are so many things to memorize, so many cycles, it will be very difficult, challenging, right? Nothing is impossible with a lot of hard work and writing habit. Anyway, so the disorder, coming to the disorders of heme synthesis, so this was all about last class's revision, right? I hope you have gone through them very well. So coming to the disorders of heme synthesis, they are collectively known as porphyrias, all right. So disorders associated with biosynthesis of heme. What is the reason? Basically, we all know the enzymes are proteins that are coded by genes that are designed for those proteins, right? And if there is some mutation in those genes, the enzyme activity will be improper, it will be reduced, and that will lead to these diseases. So all of the enzyme of heme synthesis leads to some or the other porphyrias, okay, and the problem is in mutation. So what is the generalized characteristic? Basically, increased production and excretion of porphyrins or their precursors. For example, so if we are calling the porphyrin, we already know what are porphyrins, and the precursors mean ALA and porphobilinogen. I already told you before porphobilinogen is formed, right? So delta aminolevulinic acid and porphobilinogen are the precursors, right? How are they inherited? Most of the porphyrias are inherited as autosomal dominant, AD, very important, all right. So can we classify the porphyrias? Yes, depending on the symptoms, depending on the metabolic pattern, they can be classified, right. They can be broadly divided into hepatic porphyrias, erythropoietic porphyrias, and a mixed variety, basically some porphyria which has got both erythropoietic and hepatic abnormality, okay. There are some other ways the porphyria can be classified: congenital or acquired, acute or chronic, okay. Even some porphyrias are also called cutaneous porphyrias and non-cutaneous porphyrias. So depending on your textbook, it can be, or depending on the presentation of the patient, it can be classified in many ways. We will be discussing everything. So this is the pathway, but now you already know the compounds that are appearing sequentially, and you already know the name of the enzymes with the help of two beautiful mnemonics, right. But then again you need to remember the diseases that are caused by deficiency of these enzymes, okay. So the first important name that we need to remember is acute intermittent porphyria. It is caused due to the deficiency of the enzyme porphobilinogen deaminase or hydroxymethylbilane synthase, HMB synthase, same enzyme HMB synthase, the same enzyme deficiency leads to acute intermittent porphyria, followed by congenital erythropoietic porphyria due to the deficiency of uroporphyrinogen 3 co-synthase. The next name that we need to remember due to the deficiency of uroporphyrinogen decarboxylase is porphyria cutanea tarda, abbreviated as PCT. All of these have got abbreviation. This is AIP, this is CEP, okay. Hereditary coproporphyria due to deficiency of coproporphyrinogen oxidase, variegate porphyria or porphyria variegata, okay, due to deficiency of protoporphyrinogen oxidase, and finally the deficiency of heme synthase or ferrochelatase. Ferrochelatase deficiency leads to hereditary protoporphyria or erythropoietic protoporphyria. The name protoporphyria is very important, all right. So again there are a lot of names that you need to remember. Well, you can remember them by memorizing this phrase: all congenital porphyria have variable presentations, okay, presentations right. So how does it help you to remember? Acute intermittent porphyria, congenital erythropoietic porphyria, porphyria cutanea tarda, hereditary coproporphyria, variegate and protoporphyria, alright. So, all congenital porphyria have variable presentation. This is a phrase, a mnemonic by which again you can remember the names, right. So, there is a lot of memorization that you need to do, and these are the keys by which you can take the help of these keys to memorize them in sequence. Okay. The first two enzymes that I did not mention are not that much important. These are the ones that are most common, the 6 varieties of porphyria. However, there are two enzymes, the enzyme before hydroxymethylbilane synthase, that is a rate, I mean this enzyme ALA dehydratase, the deficiency of this enzyme leads to ALA dehydratase porphyria or DOS porphyria. It is very rare. Till date less than 10 cases in the whole world has been reported. So, you can upon billions and billions of population, only less than 10 cases have been reported. It is not 10 in 100 or 10 in a million, it is total 10 till date in world population, right. So, it is very rare. So, we do not consider it as a thing to be worried about while diagnosing the disease. Why we are studying the whole course? Because we are making ourselves proficient enough so that we can diagnose the most common disorders, right. One goal of this course is definitely that. And the first enzyme, that is ALA synthase, right, the deficiency of that enzyme does not lead to porphyria at all. It leads to a disease that is known as X-linked sideroblastic anemia, all right. So, we are calling about, I mean talking about deficiency of all the enzymes. The deficiency of all of these enzymes produces some form or the other of porphyria. This is a very rare ALA dehydratase, therefore, we do not consider it at all, and ALA synthase deficiency does not produce porphyria. However, one very important thing to note, and you also probably remember what I told you in the last class, that once heme is synthesized, it actually inhibits its own production by inhibiting the feedback, I mean by means of feedback inhibition, it influences the enzyme ALA synthase. This is the rate limiting enzyme, right. So, if somehow there is a situation where, so once we have heme, the production of more and more heme, when the required amount is reached, it is not, I mean the excess heme is not produced, therefore, excess degradation product is not a thing to worry about normally. But if due to some reason the inhibition of heme on the rate limiting enzyme is lost, right, or if there is a situation where the activity of this enzyme is actually increased due to some reason, then there will be a problem. Then there will be a problem that all of these products will be produced more and more, and that is exactly the problem when there is a specific disease that is known as X-linked dominant protoporphyria. Mind it, X-linked dominant protoporphyria, where we are not dealing with any deficiency, but we are dealing with a gain of function mutation. A mutation happens due to which this have been reported very recently, right. So, in older edition textbooks this disease might not even be documented, right. So, a gain of mutation function leads to an excess production of all of these products, right. So, all of these products will be excreted in urine and it will lead to a common symptom that we will be discussing very soon, and moreover this has been found due to a gain of mutation of ALA synthase 2, right, which is actually present in erythrocytes, erythroid variety, which has no effect of heme as a feedback inhibition. So, all of this phenomena leads to a peculiar disease which is also very rare, but gain of mutation function, and the name of the disease is X-linked dominant protoporphyria, and as you have guessed by now, the inheritance is X-linked dominant, right, sex chromosome, not autosomal, unlike the other porphyrias. So, let us discuss the first important porphyria, that is acute intermittent porphyria. This is the stage where this enzyme is inhibited. So, there will be no synthesis of uroporphyrinogen 3, right. So, porphobilinogen, so after porphobilinogen there was synthesis of hydroxymethylbilane, right. So, basically hydroxymethylbilane synthesis will be hampered, right, not porphobilinogen, not urobilinogen. So, this will not be synthesized. So, deficiency of the enzyme hydroxymethylbilane synthase or porphobilinogen deaminase, which is coded by the HMBS gene. Remember, hydroxymethylbilane synthase is the newer name, and uroporphyrinogen 1 synthase was actually the older name. Porphobilinogen deaminase, uroporphyrinogen 1 synthase, these are all older names. Hydroxymethylbilane synthase is the newer name. The linear tetrapyrrole was named hydroxymethylbilane much later compared to when the whole synthesis was discovered, right. So, what happens? Naturally the previous products, that is delta aminolevulinic acid and porphobilinogen level will rise, all right, and since heme synthesis is not happening, ultimately since there is a, if there is a block here, the heme synthesis will not happen, right, and therefore the inhibition of the previous enzymes due to feedback inhibition will not happen. Therefore, a secondary increase in activity of ALA synthase is happening, because the end product inhibition is not effective, right. So, this is the basic pathology of the disease, which is known as acute intermittent porphyria, AIP. So, why it is named acute intermittent, right? Acute because of the symptoms, intermittent also because of the symptoms. Patients present with vague symptoms which are intermittent, it happens time after time, okay, it will not happen continuously, right. And what is the symptoms? Acute abdominal pain, that is the most common symptom of acute intermittent porphyria. Patient will present with excruciating pain abdomen, right, and this is one of the medical reason of pain abdomen. Mind it, in medical science there are multiple reasons of pain abdomen. For example, even now you can probably enlist multiple reasons of pain abdomen, for example problem in gallbladder, appendix, stomach, pancreas, so on. There are multiple